What is the earliest instantiation of quantum physics and quantum mechanics? And when does that in the history of physics become viable as a mathematical foundation?
So, for a since very early stage, people notice that there are some discrepancy that is hard to understand under, for example, Dalton's proposed atomic model. There are some macroscopic properties that differ vastly from material to material. For example, the electrical conductivity of fused quartz versus electrical conductivity on silver, they are hugely different. And if everything is made up of matter, then what is exactly going on inside atoms if everything is composed of atoms? So that is the question that people had in their mind. And slowly in the starting from after 1850s, people started asking some concrete question based on experimental data. So, for example, Angstrom did an experiment where he warmed up hydrogen gas and then let it cool down and looked at the spectrum and noticed some discrete lines. And also, some people subsequently noticed that those discrete lines follow some algebraic rules that people had no idea where this is coming from. So these were the first experiments that had no clear answer from the classical understanding of physics. Now, one of the earliest proposal of what the so-called old quantum theory came from Max Planck in 1901, when Max Planck started thinking about something called Blackbody. So Blackbody is a physical object which absorbs all the light that are incident on it and emits only heat energy. And if you calculate, so Max Planck showed that if you calculate the distribution of energy for every wavelength, previously the theoretical result even did not make any sense. So that used to diverge. So Max Planck showed that if you assume that energy gets absorbed and emitted through packets, like small quanta, where each packet contains exactly the amount of energy that is proportional to the frequency of that energy in that packet, then it is possible to derive the distribution that is observed experimentally for black body. This is used to, at that time, people used to call this ultraviolet catastrophe. And that was the beginning of the proposal. And then later, Niels Bohr, based on the similar idea, proposed something very drastic. He said that, okay, if we are trying to understand the atom that is done in Rutherford's experiment using the solar system model, that is not going to completely work, because that is not going to completely follow the Maxwell's theory of electromagnetism, because Maxwell's theory of electromagnetism says any charged object, if it is accelerated, it actually emits energy. Niels Bohr, on the other hand, says that something is going on inside atom, so that when electrons are in a specific quote-unquote orbits, they do not emit or absorb energy. They only emit or absorb energy when they jump from one orbit to another. So these are all the initial sporadic ideas that were emerging from a new generation of physicists at that time, and it is referred to as old quantum theory. It was not until 1925 or 26 when physicists like Heisenberg or Schrödinger, they ultimately discovered a theoretical framework that can explain the mechanics of these subatomic particles, now referred to as quantum mechanics.